after its billion-mile journey from Earth, the Voyager 1 spacecraft sent back pictures of man's closest look yet at the ring planet Saturn.
NASA says its Voyager 1 probe is sending usable information to Earth again.
18 minutes ago, Voyager 1 got a horrifying message spelling disaster for humanity.
The initial calculations showed that we were going to be in great danger of getting really fuzzy pictures if we didn't do something to the spacecraft.
Launched over 40 years ago, Voyager 1 has traveled farther than any other spacecraft into vast, unknown, and uncharted space. The strange, eerie sounds it detected are even more intriguing, shattering space's silence and hinting at unknown puzzles. Why should we stop exploring space altogether after this horrible sign? Let us explore why we have to prepare for this incoming danger 15.1 billion miles away from home. Shocking news from Voyager 1's latest discoveries. The latest news from this unexplored part of space, which Voyager 1 sent back to Earth, has everyone feeling uneasy. To really get what these discoveries mean for our solar system, let's rewind and look at the big moment when Voyager 1 was launched into space. Getting the whole story might help us see just how much this spacecraft has achieved. We should also talk about a guy named Gary Flandro. He's a big reason why these spacecraft were able to go on their missions. Flandro's story begins when he got a job where his task was to work out how to use the gravity of planets to help spacecraft move faster and change directions. This trick is called gravity assist. It's like using a planet's pull as a slingshot to speed up and steer a spacecraft. Flandro first used this idea for the Mariner 10, which flew by Venus and Mercury. After that success, his bosses wondered if the same trick could work for travels to farther planets like Jupiter or Neptune. Flandro got to work, figuring out where each planet would be and when. This was important for planning the best route. It wasn't long before he discovered something pretty big that would help everyone. In the 1980s, he found out that the 4 outer planets, excluding Pluto, which was still counted as a planet back then, would line up on one side of the sun. This rare alignment, happening once every 176 years, was a perfect opportunity. It meant they could visit all these planets in one mission, cutting down travel time by 20 years. Flandro worked out the paths the spacecraft needed to take to use these planetary alignments. He made simulations, and other engineers checked and agreed they would work. Flandro told his bosses at National Aeronautics and Space Administration about his findings, and they started planning the mission we know as Voyager. But that's just the start of the story. These 2 spacecraft, Voyager 1 and Voyager 2, have been on quite an adventure since their launches. Over the decades, they've sent back loads of information about the planets they visited and beyond. They've taken photos, measured all sorts of space conditions, and basically have been our eyes and ears in places humans can't go. Their data has changed how we see our solar system, and even how we think about space travel and exploration. Each discovery they send back reshapes our understanding of things like the atmosphere of Jupiter or the rings of Saturn. And it's not just the big stuff. They catch details that can seem small, but tell us a lot about how planets and moons behave. Plus, their travel hasn't just been about snapping pictures and taking measurements. It's also about testing our technology, seeing how far and how long we can keep these spacecraft working as they travel further into space. These spacecraft, Voyager 1 and Voyager 2, were loaded with something pretty unique, a 12-inch gold-plated record containing sounds and images representing Earth's diverse life and cultures. This included classical music by Bach, the sound of children laughing, dolphins playing, and crickets chirping. Even President Jimmy Carter got in on the action, recording a greeting in the off chance some aliens might find it. The idea was to let any potential extraterrestrial beings know we're here. They also thought it might be a way for future humans, maybe stumbling upon these records in the far-off future, to get a snapshot of life back in the 20th century. While this might sound like a fun way to say hello across space and time, it's also sparked a bit of controversy. Some folks think broadcasting our location into space is risky business, inviting potential alien visitors who might not come in peace. Despite these concerns, no extraterrestrials have dropped by yet, and it's been nearly 50 years. Next, we explore the Voyager spacecraft's grand travel through the solar system, uncovering secrets from each planet they visit. Voyager 2's epic tour of the planets. Voyager 2 was the grand tourer, taking its time to visit Jupiter in July 1979, and then Saturn in August 1981. When it was still working perfectly after all that, the National Aeronautics and Space Administration decided it might as well keep going. They sent it off to Uranus, extending what they then started calling the Voyager Neptune Interstellar Mission. Voyager 1, on the other hand, was a bit of a speedster. It reached Jupiter by March 1979 and made it to Saturn by November 1980. It got some great shots and sounds of these planets, especially during its flyby of Saturn's big moon, Titan. After that, it veered away from the rest of the solar system's plane, heading into the vast unknown. Voyager 2 finally made it to Uranus on January 24th, 1986. It took a long time to get there, 5 years after leaving Saturn, and almost 1 billion miles later. What it found and sent back was not just your everyday space data. It gave us close-up photos and details about Uranus, its hard-to-see rings, and its moons. Before this, nobody had such clear information about Uranus, and it really stirred up excitement among space enthusiasts and scientists. It was like getting a first real look at a place everyone knew existed but didn't know much about. Then, Voyager 2 kept moving. After a quick visit to Neptune in August 1989, it didn't just stop. It kept going on what they now call the Voyager Interstellar Mission. This fancy name means it's now going beyond just looking at planets. Its brother, Voyager 1, was doing something similar but was further out, exploring the bigger space between planets. Scientists are watching closely because they expect Voyager 1 to reach an area called the heliopause soon. This is the edge of our sun's magnetic pull, where the influence of our solar system ends and the vast, empty space of the rest of the galaxy begins. We'll explore more about this area and what it means later on. Rewinding to when the Voyagers first encountered Jupiter, the experience was a real eye-opener. For hundreds of years, astronomers had been peeking at Jupiter through telescopes, thinking they had a good handle on what it was all about. But when Voyagers got there, they delivered over 33,000 photos that showed a lot more than anyone on Earth had seen before. One of the biggest revelations was about the Great Red Spot, a giant storm on Jupiter. Before the Voyagers, people knew it existed, but seeing it up close showed that it was a massive spinning storm, bigger than Earth, with winds blasting faster than any hurricane we could imagine on Earth, and it had been spinning like that for over 300 years. Besides the massive red spot, Voyager spotted other, smaller stormy swirls and weather patterns across Jupiter's striped clouds. These findings were surprising to scientists because they challenged previous ideas about the planet's atmosphere. How could such wild weather last so long? It seemed Jupiter had some tricks up its sleeve that kept these storms going for centuries, almost like it was showing off just how wild a planet could get. These discoveries from the Voyager missions have made scientists rethink a lot of what we thought we knew about the outer planets. Every new bit of data forces us to update our textbooks and question our old theories. As Voyager 2 continued its trip into the unknown, and Voyager 1 ventured towards the edge of the sun's influence, there was a sense of anticipation about what they might find next. What more could these distant travelers tell us about the far reaches of our solar system and beyond? The big shocker at Jupiter was finding out that Io, one of its moons, wasn't just sitting there quietly. It was bursting with volcanoes. Before this, everyone pretty much thought volcanoes were Earth's special thing. But during the Voyager visits, they saw 9 volcanoes on Io spewing stuff into space. That sure changed the way we think about moons in our solar system. Then there's Europa, another one of Jupiter's moons. It looked pretty calm and cool with its thick, icy shell that goes down about 60 miles. From far away, Voyager 1's first snaps showed Europa crisscrossed with lines that made it look like it had some big, deep cuts or canyons. But when Voyager 2 got a closer look with better, sharper photos, those supposed big canyons didn't look so dramatic. They seemed more like simple scratches on the surface. This made some folks wonder if Europa might be hiding its own quieter volcanoes under all that ice, not doing as much show-off as Io. Next up was Ganymede, which turned out to be the biggest moon of them all. It's got 2 types of ground. One part is all groovy with lines, and the other part is covered in craters. People think this might be because there's some stretching and squeezing going on under Ganymede's icy skin, which is messing with its surface. And guess what? All this cool stuff didn't just make Voyager 2 stick around. It used the gravity from these moons to slingshot itself super fast towards Uranus, like it was getting a massive speed boost. When Voyager got a good look at Saturn, it figured out that Saturn has at least 17 moons. This was big news back then. And it wasn't just the moons. Saturn itself was full of surprises. The Voyagers took a closer look at the planet's atmosphere and found all sorts of weather happening. Sure, Saturn's storms aren't as flashy as Jupiter's Great Red Spot, but they're still pretty interesting. They found small, stormy spots and other weird weather patterns swirling around. Join us as we get a closer look at Saturn through Voyager 2's eyes, discovering its beauty and the complex activities around it, exploring Neptune's unbelievable storms. But the real drama was with Saturn's rings. Turns out these rings weren't just sitting pretty around the planet. They were actually made up of bits and pieces from what used to be bigger moons. These moons got smashed up by space rocks and comets, and now all that's left is ring material. Even Saturn's tiniest moons are just chunks from these cosmic collisions. It's like Saturn is surrounded by the leftovers of some serious space wreckage. One of the coolest finds was Titan, Saturn's big moon, which has a thick, hazy atmosphere. This place is so wrapped up in its own gases that it's got scientists thinking it might look a lot like what Earth was like before any life started here. That's got everyone excited, because it's like peeking at Earth's baby pictures, seeing what our own planet might have been like billions of years ago. Mimas, one of the moons circling Saturn, has a huge crater so big it almost ripped the moon apart. When the Voyager spacecrafts took off to explore the outer planets, both of them checked out Jupiter and Saturn. However, after Saturn, Voyager 1 decided to leave the neighborhood and head out toward the space between the stars. That left Voyager 2 to handle the visits to Uranus and Neptune all by itself. It was during these visits that Voyager 2 found out Uranus was tipped over on its side, which was doing funny things to the planet's magnetic field, making it all twisted and weird. Before Voyager 2 arrived, no one had a clue about these strange goings-on with Uranus's magnetic field. This visit by Voyager 2 also boosted Uranus's moon count from 5 to 15. It discovered 10 new moons nobody knew about before. Among these, Miranda caught everyone's attention because it looked so different. It was all mixed up with different kinds of ground and features, suggesting it had a pretty rough history, including getting hit hard by something that cracked it open. This massive impact might have had a hand in creating the rings around Uranus, which are much younger than the rings around Jupiter and Saturn. The thinking is that these rings came from moons that got destroyed by getting too close to Uranus or by smashing into each other at high speeds. Further out, Voyager 2 took some time around Neptune and figured out a day there lasts only about 16 hours. It figured this out by picking up signals related to Neptune's magnetic field. Neptune also has super-fast winds, the fastest recorded on any planet, blowing at 1,000 miles per hour. There's also a big dark storm on Neptune, similar to the famous Great Red Spot on Jupiter, but it's darker and less noticeable. Neptune's largest moon, Triton, is incredibly cold, with temperatures dipping to minus 235 degrees Celsius. Despite the cold, Triton is geologically active, with geysers that erupt, sending dark dust and invisible nitrogen gas shooting into the sky. Its orbit goes the opposite direction of most moons, suggesting that it was captured by Neptune's gravity and didn't originally form there. Voyager 2 didn't just stop at taking pictures, it also named several new moons it found around Neptune: Proteus, Lissa, Galatea, Despina, Thalassa, and Naiad. Plus, it confirmed Neptune's rings, which are so thin and faint that you can't see them from Earth. Now imagine standing on Miranda, which is just 470 kilometers across, pretty small as moons go. The gravity is so light here that you'd feel much lighter than on Earth. The surface of Miranda is like a wild collage of towering cliffs and flat terraces, mixing old and new surfaces in a way that's really out of the ordinary. The landscape tells stories of violent impacts and a scrambled history, making it a place that's both fascinating and a bit daunting to explore. The story of the Voyager spacecrafts is a mix of groundbreaking discoveries and some classic hesitations from the bigwigs at National Aeronautics and Space Administration. Originally, these high-flying space probes were meant to snap some final pictures of the outer planets and then, basically, retire quietly. But Carl Sagan, who was a key player on the imaging team and always had his eyes on the stars, wasn't having any of that. He pushed hard, arguing that there was still a lot more space out there for the Voyagers to explore. The National Aeronautics and Space Administration bosses eventually agreed, surprisingly flexible in their decision, and thus extended the mission's scope to probe the deeper realms of space beyond our solar system. Even though this new mission was set, National Aeronautics and Space Administration still decided to turn off the spacecraft cameras to save power, which feels a bit like deciding to keep your race car but not fill it with fuel. Nevertheless, before the cameras were shut down for good, Voyager 1 took a moment to glance back at Earth one last time on February 14th, 1990. This wasn't just any look back. It captured what would become an iconic image known as the pale blue dot. This photo showed Earth as a tiny, barely visible point against the vast backdrop of space, located 3.8 billion miles away. Carl Sagan, who coined the term, saw this as a profound reminder of our planet's smallness in the vast cosmos. So how do these veteran space probes keep sending data back to Earth from such unimaginable distances? Well, each Voyager is kitted out like a floating laboratory. They carry tools and instruments that would make any tech enthusiast green with envy. We're talking about ultraviolet and infrared sensors that see things in space that our eyes can't, a plasma wave subsystem for checking out space weather, a magnetometer for detecting magnetic fields, and even old-fashioned television cameras, among other high-tech gadgets. These tools enable the Voyagers to conduct a whopping 10 different scientific experiments, proving that even older technology can still kick some serious cosmic butt. The Voyagers continue to tell us stories from far away, explaining unusual worlds and cosmic events that are hard to believe. How Voyager talks from deep space. To stay in touch with Earth, the Voyagers rely on National Aeronautics and Space Administration's Deep Space Network, which is pretty much the ultimate long-distance phone system for space. This network is not your typical setup. It consists of enormous dishes measuring 70 meters across, strategically placed around the world from the dusty stretches of California to the remote expanses of Australia. These dishes act like giant ears, listening intently for the faintest peeps from our distant robotic explorers. They also shout back, sending commands across the solar system's void, ensuring that the Voyagers keep doing their job even from billions of miles away. Imagine these dishes as the unsung heroes of space communication, tirelessly bridging the gap between humanity and its farthest flung mechanical emissaries. Every bit of data these dishes catch sheds light on unknown aspects of space, helping scientists piece together how our solar system fits into the wider universe. This setup not only epitomizes human ingenuity, but also our relentless curiosity and refusal to stop exploring, no matter how distant the frontier. As the Voyagers sail through the uncharted waters of interstellar space, they continue to send back valuable information, thanks to their suite of scientific instruments and the global earpiece provided by the Deep Space Network. It's a narrative about pushing limits, extending the life and utility of what was once considered near the end of its travel, and the continuous thirst to learn more about the space that surrounds our tiny, pale blue dot. This ongoing communication and exploration are a testament to human creativity and our never-ending quest to understand more about the cosmos, ensuring that these pioneering spacecraft continue to contribute to our knowledge long after their expected retirement. As these spacecraft traveled far from the cozy embrace of the sun, the idea of using solar panels was quickly dismissed. Instead, scientists turned to a more robust solution: radioisotope thermoelectric generators, or RTGs for short. These generators take advantage of the heat generated by the decay of plutonium stored on board. This decay process isn't quick. A piece of plutonium takes 88 years to lose half its energy. So, this setup provides a steady power supply that keeps the spacecraft's instruments, radio, and computers running. The smart guesswork says that these space explorers, the Voyagers, should keep sending us valuable data for about 3 more decades, assuming all goes well and their signal remains strong enough to reach Earth through what's called the Deep Space Network. After nearly half a century since they left Earth, these Voyagers are far from being old junk floating aimlessly in space. They're still out there, doing important work. Let's dive deeper into what they've encountered far beyond the protective bubble of our solar system. A significant moment occurred on August 25th, 2012, when Voyager 1 officially left the influence of the Sun and stepped into the area between the stars, known as interstellar space. Voyager 2 isn't too far behind its companion, with both spacecraft having crossed an invisible boundary known as the heliopause. This boundary marks where the Sun's influence ends and the vast, uncontrolled expanse begins. In this new environment, both spacecraft are busy gathering and analyzing data from space particles in various fields. Voyager 1, in particular, had an interesting experience as it crossed into interstellar space. The spacecraft detected something unusual at the heliopause, a kind of humming noise that was unexpected because outer space is typically silent. Back on Earth, the teams of experts at National Aeronautics and Space Administration were puzzled by this development. They hadn't anticipated hearing anything like it. The noise seemed to come not from a distinct source, but from space itself. The scientists proposed some guesses to explain this weird finding. One idea was that this hum might indicate some kind of cosmic anomaly, something unusual happening in space that we don't fully understand yet. Another, even more intriguing possibility was that this sound could be a communication from an alien civilization. This possibility piqued everyone's interest because it might mean answering a big question that has lingered for ages. Are we alone in the universe? However, while the idea of discovering extraterrestrial life is exciting, it also comes with a dose of caution. We have no idea if such a civilization would be friendly. This eerie humming from the depths of space reminds us that while it's thrilling to discover potential neighbors in the universe, we must also be careful and prepared for all possibilities. While the scientists were still trying to make sense of an unusual humming sound detected by Voyager 1, the spacecraft threw another big discovery their way. It caught images of a gigantic swirling mass of gas and dust that seems to cover millions of miles. This might be the Oort cloud, a topic we'll dive into more later in this video. There's a genuine concern among those tracking Voyager 1's progress about whether it can make it through this vast cloud unscathed. This anxiety isn't baseless. The spacecraft's escape from the reach of our solar system was anything but smooth. When it was crossing the heliopause, the edge of the Sun's influence where the solar system ends and interstellar space begins, the electrons around Voyager 1 were thrown into chaos due to a solar eruption that just happened to occur at the same time. As Voyager 1 enters the edges of interstellar space, we look at how its travel still affects our understanding of deep space. Mapping the edge of our solar system. Let's clear up a misconception. The heliosphere isn't some far-flung interstellar realm. It's more like the outskirts of our solar neighborhood, marking the line where the Sun's presence fades and the broader galaxy begins. Voyager 1's trip has allowed us to map out the heliopause with surprising accuracy. It's now estimated to be somewhere between 90 and 120 astronomical units from the Sun. That's a staggering 8.37 to 11.16 billion miles away. Both Voyagers have now taken on new roles as space-based ultraviolet observatories, providing astronomers with a unique platform from which to observe stars and other celestial objects emitting ultraviolet light. Looking at the present state of Voyager 1, its array of tools has significantly diminished. Only the ultraviolet spectrometer remains operational. In a bid to conserve the spacecraft's dwindling power reserves, National Aeronautics and Space Administration has turned off the heating for the infrared spectrometer and the scan platform. The thought process is that the ultraviolet spectrometer can still function without these heaters for some time. Despite this, other instruments that measure particles and fields in space are still active, continuously sending back data to Earth. This ongoing transmission keeps feeding the scientific community's hunger for deeper knowledge about our universe. Let's step back and reflect on this situation. Here we have a spacecraft, Voyager 1, launched decades ago, now millions of miles from home, teetering on the edge of unknown cosmic territories. Its travel through the heliopause has turned it into a sort of cosmic guinea pig, testing the limits of human-made technology in an environment about as unfriendly as they come. The concerns about its ability to navigate through the Oort cloud aren't just about the physical safety of the spacecraft. They echo deeper questions about our readiness to face the unknown challenges of space exploration. This cloud of gas and dust represents more than just physical barriers. It symbolizes the vast, unexplored stretches of space that still lie beyond our grasp. As of the year 2022, expectations are set for receiving data from the Voyager spacecraft for just 6 more years. After this period, National Aeronautics and Space Administration plans to turn off the instruments aboard these spacecraft, leading to a complete halt in communications by the end of the 2020s. The endgame here is somewhat underwhelming. These once glorious explorers of space will be reduced to silence, floating endlessly through the cold, dark reaches of space. Despite this impending silence, predictions suggest they will continue drifting farther away from us, into the less charted regions of space. According to National Aeronautics and Space Administration's calculations, the next significant milestone for the Voyagers involves passing through the Oort cloud, a vast collection of icy objects that forms a sort of outer shell around our solar system. This area lies well beyond the Kuiper Belt and represents one of the frontier zones of interstellar space. If the Voyagers manage to navigate through this dense cloud without suffering damage, they will eventually, over a span of 16,700 years, drift close to Proxima Centauri, the nearest star system to ours. If you can stretch your patience further, in about 30,000 years after leaving the Oort cloud, these spacecraft will supposedly reach the center of the Milky Way galaxy, where they are expected to orbit for millions of years. Voyager 2, for its part, has not been outdone. It spurred further investigations into the nature and dynamics of ice giant planets within our solar system, and perhaps in others as well. These insights have inspired a slew of follow-up missions, such as the upcoming Dragonfly mission to Titan, which aims to further explore this strange moon. Additionally, the Europa Clipper mission targets Jupiter's icy moon Europa to investigate its potential for hosting life, and the ambitious Uranus Orbiter and Probe mission plans to study Ariel and Miranda, 2 of Uranus's moons. These ongoing and future missions, conceived almost 50 years after the Voyagers were launched, underscore the enduring legacy of these pathfinders. They not only charted a course for modern space exploration, but also laid a robust foundation for the next generation of missions aimed at unraveling the complex dynamics of our universe. With such a flurry of exploratory missions on the horizon, one might speculate whether we will ever fully understand the vast complexities of space, or whether we are just scratching the surface of a narrative that extends far beyond our current scientific reach. Through these missions and the continuing analysis of the data they return, humanity's quest to understand the universe grows ever more intricate and layered. Each mission builds on the past, pushes current boundaries, and sets the stage for future discoveries. As the Voyagers silently coast through the cosmos, their legacy continues to spark new questions, drive technological advancements, and inspire a global audience captivated by the puzzles of space. Their travel, though no longer active in communication, still guides us as we delve deeper into the cosmic unknown, demonstrating the incredible reach of human curiosity and our relentless pursuit of knowledge. Could the unsettling sounds Voyager 1 has captured be signals from an unknown cosmic entity, or are they simply echoes of cosmic dust? What do you think lies beyond the eerie silence of space? Share your thoughts, and don't forget to like and subscribe for more deep space news and updates.